Okay, welcome back everybody. This will be the last part to this series on solubility product constants, and for the last question we'll be addressing it will be dealing with this with solubility from two different sources. Okay, so for this question we're trying to determine the concentration of magnesium, and we're given, okay, I haven't given you guys a value yet, but we're given a value for how many moles of this there are. Okay, so we're going to assume, okay, so experimentally what will happen is that we have this chunky sodium fluoride, solid, ionic solid, and we're going to start dumping it into this beaker full of water. Okay, just for simplicity, we'll just say that the water is 1 liter of water. Okay, that's the volume. So we're going to dump the sodium fluoride. We're going to dump more sodium fluoride into this beaker of water, and eventually is going to start to precipitate. So this is the initial state, and this will be the final state. Okay, and then the final state will start to have some magnesium fluoride, MgF2. Okay, so the whole point of this is to get to a degree where we can start to precipitate it out. And our whole question is asking, well, what is the concentration of magnesium given that we know this value? And we'll just assume, just to be simple, that the amount of sodium fluoride added into this beaker, we'll just say is 0.1 mole, okay, of sodium fluoride. Okay, added. That's a very small amount, and realistically I don't think it would precipitate, but again, I want you guys to understand the concept. Okay, so again, we're adding sodium fluoride into this beaker full of magnesium, and is going to eventually precipitate from a solid. Question we're trying to answer is, what is the concentration of magnesium? Okay, so we know a few values. Well, we know in essence we know the value of the fluorine, because the way we form this precipitate magnesium fluoride is between magnesium and fluorine. So we need to know the concentration of fluorine, right? Because the expression that we've been dealing with is magnesium 2 plus fluorine minus, and that's equal to the KSP, right? So, and this is squared. Okay, so let's find the moles of fluorine, and then we can find the concentration because we have volume. Okay, so we could just figure this out even without doing the calculation, but we'll just do it anyways. So if you have 0.1 moles of sodium fluoride, right, you get 1 mole. For every mole of sodium fluoride, there's 1 mole of fluoride ions, and that will be equal to 0.1 moles of fluorine ions, right? And we divide this by 1 liter, right, because molarity is in units of moles per liter, 1 liter, and that will give you 0.1 molar fluorine ions. Okay, so we figured out the concentration of fluorine. Okay, so let's erase this stuff. Okay, so here are the things we know. We know the concentration of fluorine, and that's equal to 0.1 molar. We're trying to figure out the concentration of magnesium 2 plus, which causes precipitation to occur. So that's the question we're trying to answer, and we know the KSP. Okay, we should always know the KSP. 5.2 times 10 to the negative 11. Okay, so all we do in these cases, okay, when we have two different sources, we will just plug these values into our expression. Our expression is, again, Mg2 plus fluorine minus squared equal to KSP. We'll plug these values into this expression right here, and that will give us our value. Okay, and I know some of you guys you guys are developing these questions, starting to get confused about a specific thing I'm not doing, and I'll address that thing. Okay, so don't worry. And if you guys are not thinking about the thing I'm going to address, then you guys are good to go. So fluorine is 0.1, so we plug in 0.1, we square it. We don't know the concentration of magnesium 2 plus, okay? And it's equal to 5.2 times 10 to the negative 11, right? Let me actually there's some space to do this because it's looking a little bit messy. So we know that the is going to be magnesium 2 plus will be 0.1 squared equals 5.2 times 10 to the negative 11, right? So now all we do is solve for magnesium concentration. Let's see what this is. I've done this calculation quite a few times, so I should know. It's 5, no, yeah, I forgot. Hold on 1 second. Yeah, it should be 5.2 times 10 to the negative 9. Double check with a calculator, even though I'm pretty sure that's right. Negative 11 equals that divided by 0.1 squared. Yep. Okay, 5.2 times 10 to the negative 9, and that's the answer, and that's it. Now, okay, the question, okay, the question that some of you guys are, you know, asking right now to yourself, like, what is this guy doing? Okay. Well, the question is, why didn't we use an ice table? That's one of the questions you guys may be thinking. Or, why didn't we plug in 2x for the concentration of fluorine? Why didn't we multiply 0.1 by 2, right? Because initially, let me erase this diagram here. This little picture right here. Okay. Initially, when we didn't have magnesium and fluorine coming from two different sources, when they're initially in the earlier videos, when they're coming from one source, we set it up like this: MgF2, Mg2 plus 2F minus, and when we did our ice table, ICE 0x 2x, right? The equilibrium is initial plus change, so it'll be x, it'll be initial plus change, it'll be 2x. So then we plugged in into our expression x 2x squared is equal to the KSP value. Okay, so you guys are saying, well, what is this guy doing? Okay, why didn't he multiply this 0.1 by 2? Didn't we do that in the last time? Well, the reason why we are not doing this is because of the situation. In this situation over here, we had a beaker, right? Chunky magnesium fluoride, a chunk of magnesium fluoride, dumped it in there, some water, okay? Dumped into some water. You get this picture in the diagram. Okay, right? We got some magnesium fluoride dumped in some water, and then it starts to dissolve to generate these ions. Again, these ions are based off of this magnesium fluoride dissolving. Okay, so in this case, the problem that we did, okay, so this whole thing does not apply to our situation. Our situation is very unique. When you have two different sources, okay, just keep this in mind. I'm gonna try to keep this as simple as possible. When you have two different sources, like the case we had, right? We had Mg2 plus ions already present, and we dumped in sodium fluoride. This is one source. This magnesium ions is from a different source. When we dump this into here, all we do, okay, actually, when we dump this into here, we form a precipitate. Okay, all we do is plug in the values into our expression, calculate for magnesium, the concentration or whatever concentration that is being asked by in the question. In this case, we're dealing with one source, so it's understandable that we'll get a 2-to-1 ratio. In this case, we don't know where the magnesium came from. We don't know the concentration of magnesium. Okay, so there's no type of ratio because, again, I'm gonna constantly stress this, that it came from one source. So therefore there is a 2-to-1 ratio. Okay, this 2x is based off the 2-to-1 ratio, and this 2-to-1 ratio is based off of one source. So since this 2x is based off of one source, right, it cannot be the same thing as two sources. When it's two sources, right, magnesium from one source, the other one is from another source, You just plug it into the expression. No 2x. You don't do 2 times that amount. You don't deal with that. You plug it into the expression, solve for whatever you need to solve. And in this case, we're solving for magnesium ion concentration. Okay. Again, 2 different sources. Plug it in to the value. Plug it into the expression. Solve. When it's coming from one source, like this case, then you have to be careful with coefficients and do 2x and x. Okay. So, and that's it. Okay. So figure out the concentration. For example, we're asking how much magnesium was required to precipitate out magnesium fluoride, and we realized it was 5.2 times 10 to the negative 9. Even though this question is not really that realistic, again, the purpose was to just get you guys to understand some other aspect of KSPs. So there you go. And that will conclude the series on KSPs. Again, if you guys have any questions, feel free to leave comments, and I'll do my best. I check my mail quite frequently. So if you have questions, I'll be happy to answer. And you can tell from my other videos that I answer them pretty quickly. If you want me to do some videos on some different topics, feel free to leave a comment. I'll be happy to make a video on different parts of chemistry. Actually, somebody was requesting me something, so the next video I'm going to be making will be covering aromaticity, and that's organic chemistry stuff. So again, leave some comments, questions, rate whatever you want to do, rate the video, and thank you for watching, and I hope you guys have a good one. This is Mobile 12, and I'm signing out.